Let's talk about the algebra of functions. Now that we have functions, we can do certain things with them. The first of which is add them together. So f plus g of x, what this means, what this notation right here means, is we're going to take f of x and add it to g of x. So for example, let's say we had f of x was, how about x squared plus 2x, and my g of x is equal to, how about 5x plus 7. That means f plus g of x is the new function where you take f of x, which is x squared plus 2x, and you add it to g of x, which is 5x plus 7. Combine like terms, that gives me x squared plus 7x plus 7, which you can see is a new function. And you can also evaluate a sum of two functions. So let's say I did f plus g evaluated at 1. There's two ways you can do it. You can either evaluate f of 1, add it to g of 1. If I go this way, here's f of 1. F by definition is right here. So I'm going to plug in 1. That's going to give me a 1 squared plus 2 times 1 plus, and then the g of 1. G's right here. So g of 1 is going to be 5 times 1 plus 7, which is a 1 plus 2, that's 3, plus 5 plus 7, that's 12. That gives me 15. Or if you would prefer instead, you could essentially say f plus g of 1. Well, I already found f plus g of x. That's right here. So f plus g of 1 is going to be if I just plug in 1 into there. So I'll get a 1 squared plus 7 times 1 plus 7, which is 1 plus 7 plus 7, which we can see again is 15. So there's two ways you can do it. But f plus g of x, by definition, is just take f of x, add it to g of x. Similarly, next thought, f of x minus g of x is just if you take the difference of the two of them. So for example, let's say I have f of x is equal to, well, how about the square root of x? And let's go with g of x is equal to 1 over x plus 3. That means f minus g of x will be, by definition, take f of x, that's the square root of x, and then subtract 1 over x plus 3. And unless you're asked to simplify, that's a perfectly fine answer. It's the difference of the two. Again, you could evaluate it either by plugging it into this function or evaluating it at each one of those, f evaluated the value, and then g evaluated the 0 and taking the difference. For example, if we asked about f minus g of 0, one way you could do it would be f of 0 minus g of 0. F of 0 is going to be the square root of 0, that's 0, minus g is 0. Looking at 0 here, your denominator is 3, so we'll get a 1/3, which means overall I'll get a negative 1/3 when I'm done. You can also multiply the two. So f times g of x, by definition, is f of x times g of x. So for example, if you take, let's say, f of x is equal to x plus 3, and you take g of x is equal to x minus 4, that means f times g of x will be the product of f of x, which is x plus 3, times g of x, which is x minus 4. And that's a perfectly valid answer. You could expand it if you want or leave it as it stands. Again, you could evaluate it at a number if you'd like. Last one we can do is f divided by g of x. By definition, that's f of x over g of x. So, for example, let's say f of x is just x, and g of x is equal to x squared plus 1. That would mean f divided by g of x, by definition, is going to be take f of x, that's x, divided by g of x, which is x squared plus 1. Okay, these are new functions, all four of these, f plus g, f minus g, f times g, f divided by g. They're new functions, so they have domains. Ooh, new functions. There we go. So they have domains. They also have ranges, but I want to talk about domains real quick. Well, if I can scroll back up here, if you think about the domain of f plus g of x, by definition, that's f of x plus g of x. So whatever x value you take, it better be in the domain of f, and it better be in the domain of g. Otherwise, if you can't plug it into one or the other, you can't plug it into the sum f plus g of x. So in other words, this mathematically is going to be called, what we take is the intersection of the domain of f and the domain of g, which means it has to live in both the domain of f and the domain of g. Domain of f is all real numbers, domain of g is all real numbers, so the domain of The sum, or this guy right here, is all real numbers also. Similar thought here. By definition, f minus g of x is just f of x minus g of x, so it better be in the domain of both of those. The domain of the square root of x is 0 off to infinity, including, and the domain of this is, you can be anything but -3. So in other words, the domain of, let me write this one down because I think this one is a bit more interesting. Domain of f is 0 off to infinity, and the domain of g was everything except -3. Oh, I'm going to run out of room. I'm so sorry. It's going on to the next line. But that, okay? The intersection of these two is essentially the domain of f. There's a problem at g at -3, but that's not included in here. So the domain of f minus g is going to be 0 off to infinity. So in other words, this guy's domain. 0 off to infinity. Similar thought with f times g. It's got to be the domain of f, got to be in the domain of g. Both of these domains are all real numbers, so the domain of the product is going to be all real numbers. The domain of f divided by g, well, it's got to be in f, and it's got to be in g, but g better not output as 0. Otherwise, you've divided by 0. So it's going to be the intersection of the domains less anything where g of x is equal to 0. And I really only care about real numbers in this case, so there's never going to be a time where x squared is equal to -1 without allowing complex numbers. So in this case, there's not any extra numbers to get rid of, but had I instead had a g of x was, say, just x, I'd have to eliminate 0 in there.